This is the Empower Podcast. Released June 28th, 2021. Episode 547. Open Source Mindset with Michael Gielda. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
Hey, I'm Michael. I'm a co-founder of Micro.
Welcome back, Michael. How are you doing?
Very, very well. It's been, half a year, right?
It has been, yeah, about half a year. So last time you were here, we were talking about Renode. We were talking about some of the open source toolchain stuff. Micro has not slowed down or stopped. What have you guys been doing in the meantime?
We tend to say, it's been half a year in normal time, and then it's been 10 years in Micro time, most likely. I think the biggest kind of thing to say about this time is we've been just continuing on this road to using open source in various commercial contexts, do good stuff, especially somewhere at the borderline between hardware and software. And one big kind of announcement, one big thing that has come out of our stable is the open source portal that we launched just recently. If you go to opensource.micro.com, you'll just see quite a bunch of projects that we're running and different things we contribute to, and also like the story that connects all these things, and they cover things from like ASIC design and FPGA stuff all the way up to the cloud.
Yeah.
And there's a reason for it. It's like, these things, we tend to see these things as connected.
Yeah, well, and we should remind people too. So Micro is a service company that works on a lot of different projects for different people. You've got developers, like you said, working on all these different open source projects. And some of it is like sponsored type work as well, right? So like you would be working for a particular company, and then they're not only paying you to develop this thing for them, they're also agreeing to saying, hey, yeah, you could push this stuff back into an open source repository so that other people can benefit from it.
Yeah, absolutely. I mean, this is the best case scenario, of course, and it tends to be a mix. Obviously, there are sometimes things that we're asked not to contribute back for various reasons.
Right. Yeah, I mean, there's business development type stuff or privacy, whatever, and yeah, that's up to the company.
Or stuff that's literally not interesting to anyone else. Like it does happen that like you're developing something very niche, and open sourcing it is kind of. I do tend to say that you never know. You'd be surprised, but like there are things that are obviously like it would be almost it would be a bad idea not to open source things. Like you're doing. Let's take the Renode example that we've been covering last time. Kind of we're doing a platform support in Renode for someone. If we didn't contribute it back, like what if someone else comes along and wants the exact same thing? Like you don't want to be redoing that work, especially if you had to redo it in a different way. It's like counterintuitive. Exactly. So many things that we tend to say that like you'd be surprised how many things are worthwhile, contributing back. But of course, different people have their different comfort zones, and we tend to work with companies listening to what they have to say and how they work, and we just tend to encourage them to contribute to open source. And increasingly, we are successful in encouraging people. And even we have a lot of people approaching us and saying, hey, because you work like this, because you give us all the source code and you tend to contribute things and so on, we'll work with you as opposed to someone else because this is exactly what we want to do. We want to perhaps, show ourselves as a more progressive company. We perhaps want to just kind of grow our business in various unprecedented contexts. We want to kind of be more software driven. There's various reasons, but like increasingly it's people approaching us citing specifically this methodology and this mindset. And I especially liked several times in the past year when people approached me and said, hey, I heard you on the Empower podcast and we want to work with you.
Well, that's good. Okay. Well, if anyone else wants to hire Michael, they can go through me. I'm now his agent. So Ant Micro is all business will be routed through Chris Gamble. Just give me a call. Very small, 25% commission. No, I'm just kidding. That's great. That's really great. And I think that, it's interesting to me. Like I think about, CEOs at, big co that might want to hire a software development firm or someone to help out with this particular product. My first instinct is like, well, why would they go for open source? Why would they go for this? I'm paying someone, but then it gets pushed back into the community. But the thing to remember is that they're probably already working within a context of open source anyways, right? So if they're if they've decided to put Zephyr on a board or similar and they want some extensibility for it, they've already benefited from other stuff that Antmicro has written, other stuff that other companies have written, stuff that the chip companies have written. There's like they're already bought into the ecosystem, so that has to be an easier sell than I probably first imagined.
Precisely, yeah. I mean, that's the first argument, right? You're benefiting from a lot of work that has been done by other people without you having to pay for it. So you can just imagine this transaction to just proceed into the future where whatever you contribute, other people will be happy about, and then they will perhaps do the same thing, and it tends to just self perpetuate.
Yeah, paying it forward, right?
And like a lot of our customers, we have people approaching us that are either engineers or perhaps past engineers, and they just understand how practically it's just easier to work with stuff that you can see and
Yeah,
examine.
right,
And
right.
you know a lot of people tend to experiment with some things that we've built before they actually approach us. They download something, they
Oh,
play around,
interesting.
they see it's good, and then they come and say, okay, I've been able to convince my company it's a good thing. Now let's build it out to cover whatever we need to cover, because I tend to say there's an endless amount of work to be done to
Yeah.
push
Well,
humanity forward in various fronts. So we tend to focus on like the next awesome thing to do rather than kind of fighting over like this little thing. We want to be the absolute masters of this little corner of the world. We'd rather just go into new corners and work with people that want to perform some change. And open source is a good way to do that, because if you're exploring new territory, other people they'll be a little bit skeptical, and if you just put things out there, if you show them, hey, I'm building this in the open, people will believe you much easier, because they'll see you're serious, right? This is not like vaporware, this is
yep,
not
yep.
like marketing. It's really something that's there, and you can test it out. And so like when people want to innovate, when people want to build some kind of a new capacity within their established company, many of our customers are really big companies, right? Kind of open source is a nice way to expose yourself, also to criticism sometimes, also
Sure.
it's this kind of exposure people are afraid of.
How much does it play in the idea of labor shortages? I mean, like that seems like something too. Like, so I'm looking at the open source.antmicro.com. There's a category on there, and so it's ASIC and FPGA development platforms, edge AI and software, and cloud systems. And specifically in the AI space, I just hear about like how hard it is to find software people, how hard it is to find experts in these various areas. A lot of them are very new areas. So how much is it that as well of like leaning into open source because that's where there already is some expertise, there already is a bunch of project happening, that sort of thing.
Oh, absolutely. I mean, you couldn't develop these things just by hiring 20 engineers and writing it all from scratch, right? Like, I mean, you could, and some people do, and sometimes there's a reason to write things from scratch, and we do that too. But most of the time, the problems you're facing are just they've been faced by other people before, and you can just focus on this very important part that you want to work on yourself. It's funny that you should mention AI. We've just released an AI framework called Kenning. It's also on the open source portal. And Kenning, of course, like people will ask in this XKCD famous comic, we have 14 standards, and now let's invent the 15th one.
Of
It's kind
course,
of
of
like this
course.
with both like front end frameworks and AI frameworks and so on. But first of all, we think that it's a bad argument in the sense that plurality is good, right? Like you can use whatever you want. And secondly, we just saw a missing piece. We saw that we'd like to make how different kinds of AI models and AI frameworks work across a range of AI platforms from different vendors of different types, CPUs, GPUs, FPGAs, specifically deployed on the edge. We tend to kind of build AI systems for our customers. We use different kinds of platforms, like a lot of NVIDIA, of course, but
Yeah,
also
yeah.
Intel's Movidius and Coral from Google, and RISC-V, of course, increasingly PGA stuff. So lots of different platforms, and they tend to, kind of differ because everyone wants to have their own stack, their own compiler, optimizer.
Yeah, right.
Everything's very fragmented. So we're
Mm.
kind of trying to bring it all together and make sure that these things can be compared, like an apples to apples comparison, and improved and thought of as like these are just platforms. This is just hardware. Like hardware is
Got it.
super important. It's great. It's awesome. But like for a software person, it's
Right.
it's it's just hardware that I want to run my workload.
So would that be like you'd switch out a flag and that would switch from a Movidius to like a Tegra or something similar?
Precisely, yeah.
Yeah. So you just
Mhm.
abstract away all the lower level stuff. Well, not lower level, but like all of the various types of things, and you have APIs to talk between them and things like that.
Yeah, we try to, of course, kind of expose quite a bit of functionality so that you can, this is still available to you if you want to tweak it. But
Sure,
like by
sure.
default, you're going to be able to quite quickly run a kind of model on different platforms and even generate, nice matrices of results to see
Yeah.
how they compare. Because, the
Yeah.
comparison aspect is difficult because, of course, first of all, everyone's afraid of being compared. And second of all, if you have your own AI platform, you're going to, focus on how do I protect my share of the market. I think it's a fallacy in the sense that the market to be uncovered is much bigger than the one that we have today. So I think that the cool stuff lies somewhere ahead of us. It hasn't yet been discovered. So it's I think more interesting to focus on how we can enable new stuff and how we can make AI normal, and especially edge AI, right? Like when I'm talking AI,
Sure,
I
sure.
often talk about AI that's deployed somewhere in the field. How do we make it so that it's not as kind of black magic as it sometimes is? We tend to have customers who come and say, "Oh, we want to switch from this platform to that one," and then we have to explain to them, "Well, it's not going to be that easy because suddenly
Right,
you have
right.
to switch out all the tools in your tool set to something else, and it's just because a certain platform is not supported here, or like these operations are missing from that compiler." And of course, like you can always go and try to improve those things and make them work together. The challenge is though that many of those underlying tools are closed, right? Like a lot of the AI stuff actually is pretty closed, and we've had that complaint over the years from many customers. Like they come into the edge AI space, and one of their major criticisms is that I wish I could just optimize things better, but like much of the stack is actually closed if you look deep enough.
Yeah. So, and when you say that sort of thing, I mean, so I'm looking at the projects page as well, and some of them are hardware things, some of them are moving up to firmware and software, and then network type stuff as well. So, where in the stack do you run into a brick wall? Is it like I would assume that most of these chip vendors want you to be able to put stuff on a board, but is it like you can't even get a NVIDIA datasheet or similar, or where does that happen?
It's typically in the compiler slash optimizer sphere. Data sheets, I mean, you do get data sheets, right? But like they tend to explain and describe the things that you'd normally be interacting with directly, right? So if you're like writing drivers for things, obviously you need data sheets. So like even if a vendor kind of doesn't provide a good data sheet, when people need to write drivers, they will complain, they will kind of bug them for it, and eventually they'll get what they want, right? So it's kind of almost unavoidable. Over time, data sheets tend to improve. The challenge of AI is that a lot of the time, you don't only get a platform, you also get this little binary blob that kind of goes on top, right? So you're never interacting directly with the hardware.
Ah, yep, yeah, the magic bit.
Yeah, the magic bit. And then like you never actually get to see how the hardware works internally, because like all you're talking to is like the some kind of a binary blob, right? And so you interface with something that's kind of artificial. It's not really in the hardware. It's
Right.
just some software you don't have
Are
access
you
to.
saying the right incantations? Are you waving your hands in the proper manner in order to get the black box to do what you expect the
Yep,
black box to do?
basically. And we believe that black boxes are not only bad for the users, right? They're bad for the companies making them. It's
Yeah, you're not gonna get any pull requests from a black box. That's for sure. On a black box, rather.
and you could have this tremendous firepower that people have in just optimizing. If you look like, I don't know, LLVM, right? How many people are there just sitting and optimizing those compilers, just tweaking
Yeah.
them this
Yep.
one tiny part of a percent, just because that translates to like several $100 million of income for some big company.
Right. Right. Yeah. Versus like a Kyle compiler where they have teams of engineers and they work through bugs, but they work through bugs based on what their top clients want, and they kind of do it hierarchically like that instead of Joe Schmo being like, well, I'm just gonna fix this.
We've had that actually in Renode, for example, where the people just came and said, I found a problem, but here you go, here's a
Yeah. Yeah.
fix, right? Like
Yep.
that's the
Yeah.
best kind of thing to happen to you, is like, because of course, like a bug report with good information about the bug is also very, very useful. I'm not saying that's bad.
Sure. Sure.
It's
Yeah.
it's a great thing to have, but like more often than not, people will get frustrated with the bug and they'll say, well, I was tracking it down and I found it's happening here and here's a fix. And that's kind of, I think, just playing into the nature of software engineers a little bit. Like they're stubborn people, just like I am myself.
No.
So and if you don't get access, right? If you never presented with the actual source code, like you're never going to be able to suggest what's broken because you just literally don't know. So yeah, we've been trying to, by the way, kind of explain that to a lot of people and kind of lead the way a little bit, because on the one hand, we tend to build a lot of devices for our customers where we use whatever's on the market today, and that's a variety. I mean, it's also like Snapdragons, and it's NXP stuff. It's various kinds of platforms that we just build different devices like industrial, medical, logistics, agriculture. Everyone is automating stuff these days. But we're also looking at the next gen, and we're also kind of, first of all, we're in the RISC-V International, and of course RISC-V has managed to establish some kind of a credibility by now, and everyone understands. Okay, yeah, CPUs can be open. So that's good progress. But I think that what we're really looking at is what we're trying to achieve in Chips Alliance, which is another organization focused more on the entire ASIC design process, not just the CPU, but also kind of interconnects and IOs and analog, all parts of the chip, as well as the tools that get you to actually making the chip what it is.
Yeah. So, well, let's talk before we get into the chip side of things, because it does seem, I mean, it's like you're approaching all these things and you're saying, okay, how can we be more open? How can we be more open? But let's go back to that binary blob piece. I mean, it must be at some point you've convinced people to open up some of it, maybe not all of it. What does that look like? I mean, is that getting access to lower level registers and like just more information? How does that end up working and switching over to a more open kind of mindset?
Actually, kind of convincing silicon vendors and so on to do that is very, very hard, right? And how that would
Yeah.
happen would be quite simply, hey, here's the source code for this compiler, or here's the source code for this binary blob. And a lot of people think, oh,
Well, we've had it on the show too, right? So we've had almost within a month, I believe, we had Brian Faith from QuickLogic on here. They've completely uh, gone for the open source route, and then we had Sammy Chung from Ethinix on here, and he said, "Nope, that's not us." And I asked him about it, and he said, "Look, it just doesn't feel right to us right now. It seems like they're considering it. I feel like some of it though is they haven't seen the benefit because of the long history of like providing this software and people just using the software and not pushing it back upstream. They haven't gone for it yet, right? Whereas Brian and his team, they talk to Tim, talk to you guys, and just like they're like, all right, we're all in for it.
yeah.
So what?
No, I mean, QuickLogic and Brian, they've been kind of the kind of outlier and a very good
Yeah,
example of how that could actually happen.
right.
And it's a mixture, of course, of humbleness you have to have, and I think that kind of Brian definitely shows that, and also an understanding that things won't happen overnight. Like your fate, like just open sourcing a tool chain, or it doesn't magically fix all your problems. But what it does is it puts you in a different position where you can get external help more easily,
Yeah,
and over time that accumulates into making a radical difference. But like it takes time as well, and so
sure.
the ability to kind of also just wait for this to happen without losing the faith, which coincidentally happens to be Brian's second name, is
Yeah.
is like important here. And I can understand how it's difficult to understand this. Like if you have a successful business.
And having difficult
Yeah.
situations, I think, as well, right? So like Xilinx is a many billion dollar company, or I guess they're now Altera. Right? So they who do they get bought by?
AMD. Yeah.
AMD, right? And so it's just like it's just juggernauts at a certain point, right? So convincing a Xilinx or an Altera or AMD and Intel at this point, like that's a huge thing. That's changing the direction of an aircraft carrier type of thing when an iceberg's coming their way. It's just going to take a long time,
I
but
mean,
I'm
perhaps
sure
I
that
can
it.
mention that,
Yeah, yeah.
and yeah, indeed, that's exactly how you say it. And we are already kind of working with bigger vendors in many areas, and one of them is we're building this interchange format for FPGA tooling. and we have Xilinx already contributing to that, right? So I mean,
That's great. Yeah.
this is like on the side to whatever they're doing as their main focus.
Right. Yeah. They're not dumping their IDE anytime soon, but they're
Yeah.
also, there's pieces that, you start to work together and then it builds from there.
And they can see that there's a lot of interest in research. There's some kind of niche use cases we've been able to address that we can kind of make stuff work very well. And so this mindset starts appearing when someone says, hey, why not, like we don't necessarily have to like double down and kind of make it our primary
Mm-hmm. Yeah.
tool chain, but like what if people could use that as well? And that's pretty cool.
Yeah, yeah. I mean, and so I got to the Z section and the V and the Z section of the open source board, and there's Vertex UltraScale PCIe example, and then Zinc MK boot image, Zinc video board. So that you're making hardware, you're making some FPGA examples, things like that, where there already are some paths in there to do some open source things, but it's like you said, it's not everything that Xilinx is all in on because they have other business use cases and other ways they're doing things.
Yeah. And of course, the portal is kind of just scratching the surface. Really, it's not all of our projects are even onboarded as of this point. But yeah, I mean, I think that the broadness of the topics covered there should kind of signify the one thing that we've understood throughout the years is that the pattern turns to repeat. Like everyone thinks that it's just their market that's special, but it's not true. Many of these
Right.
things, the phenomena are really really similar. I mean, it's not a coincidence that we have the Linux Foundation planting projects in different areas, like the Chips Alliance LF project and the Zephyr project. By the way, we just became platinum member. It's also Linux Foundation project, and there's many different projects out there in completely different areas. But like if you dig deep enough, you'll understand that the processes, the methods, the problems that people face tend to repeat, but everyone thinks that their problem is special.
Totally.
Whereas we're trying to show, no, 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 you don't understand. There is typically in your business, there's a huge part that could be easily open source, and like nothing would happen because most people out there, they don't care about your business enough.
Yeah, most people aren't paying attention. Yeah.
Yeah, they don't care enough about your business to be trying to kind of steal it away
Mm-hmm.
from you. They have their own
Yeah.
stuff. They're ambitious. They want to do things that are not necessarily the same things as you're doing. And even if you open source half of your stuff, like nobody's going to be able to copy it easily. Like they're not going to see
Right.
how this
Right.
all connects well. And it's a process. It's not that you kind of convince people and they see the light and then they open source everything, but it's more
Right.
like they see those little niche areas where it wouldn't hurt to open source this part, and then we can
Yeah.
do some interesting research here, or something like this.
Yeah. I mean, if I think about like, I'm going to pick on, not pick on, I'm going to keep using Xilinx as an example, right? They're huge, or now AMD, and it's like, so if Xilinx decided to make their toolchain open source, or even just part of their toolchain, or whatever, that might give some insight into some of the stuff internally, some of the structures of their logic and how they're putting things together. But does that mean that Altera is going to go and copy it right away? Maybe they'll make some marketing material against it. Okay, sure. But it's not like they're like handing away their like masks at the fab. It's not like it's not like you're just handing over the keys to the entire kingdom. So yeah, it is interesting to see what parts are valuable to a company and where the resistance actually is. I mean, I think some of it is probably just cultural as well, but
Yep.
yeah.
There's a lot of inertia as well. Like
Yes, right, right.
there's one particular thing that we get asked about a lot, and perhaps it's good to use some time to explain that. A lot of people say that they don't open source stuff, not because it's like impossible for them to do so for strategic reasons, but it's more like, if we open source it, we'll also have to support it. And people ask questions, and we don't have time, we don't have engineering power to answer those questions.
That's interesting. Because it feels like that's the opposite of what would be actually. I mean, it's like there would be then community support and that stuff.
Initially I think that's not the concern is not ridiculous, right? Like initially,
Uh-huh.
indeed, you open source something, you get a lot of questions because there is no community yet, and you don't have like 20 engineers to go and start this community, and you are afraid, rightfully so perhaps, of this initial period where you have to figure out a strategy. How do you approach difficult
Sure,
questions and people,
sure.
I don't know, poking fun at
Dealing
the
with grumpy
stuff that
engineers and
yeah, yeah, yeah. So and it's a valid fear, but it's like it should be much smaller than it actually is, because over time you can literally tell people, hey, this is open source, there's no support, and
Hmm.
and there really is no support, and that's it. Like I don't owe anyone anything because I've literally just pushed 20 years of my work open source, for example, and how do people expect me to also go and support that for 20 more years for free?
Right. Yeah.
And like, you can say that you should be open about saying what you can and cannot support, and people can be grumpy about it. People can say, oh, in that case I'm not going to use it. But many people are like, I'm like this. I go online, I see a project, and of course I like when a project is well maintained. There's a lot of issues, but at the end of the day, I look if the project is does what I want, and like, especially in the context of a company that I run, I'm like, well, it's a risk that I'll have to kind of put in work to kind of go
Yeah.
and
Yeah.
maintain this. But I mean, otherwise,
But
I'm
the
just
price is
writing
right.
things from scratch, right? Or
Yeah.
yeah, exactly. I can go and pay someone to do this. I mean, there are many ways, and it's okay to talk about it.
Yeah, and I feel like there is a false sense of security too, right? If it's like, okay, so someone's been writing a piece of software for 20 years, you've been paying a license fee for 20 years, you assume that you'll be able to pay for it 20 more years, right? There's that assumption. But if the maintainer who you've been paying money gets hit by a bus, there's there's nothing there. I mean, like it's done. That's the end. So
That's typically a fear in the open source community, but I'll translate that to the proprietary software space. Like, companies disappear.
oh, actually, I was talking about the proprietary space. Yeah.
I know, but most
Okay.
people kind of most people are associate open source with individuals, which is of course not true. But like,
Got it.
this kind of tendency of thinking about people getting hit by a bus is typically about this kind of lone maintainer of an open source
I
library
see. Yes. Yeah.
everyone's using.
Hmm.
I mean, the thing that perhaps comes to mind more directly in the closed source world is a company that just exists but then just goes bankrupt. I've just recently talked to a friend whose friend
Mm.
was running this company. It was selling licenses, and like, there was one bad year, and like they couldn't sell the licenses, and suddenly there is no plan B, right? Because in open source world, you can kind of easily pivot. You can kind of, you get so much free marketing, and you get a community that you could perhaps exploit to kind of sell other things. And there are, exploit is a bad word, right? But you like work with the community to figure out a strategy to compensate for whatever's been happening.
Mm.
Whereas if you're just literally selling people software in a box, and there's a year where the boxes don't sell well, you can be in trouble, and your company goes under, and you've got nothing. Like suddenly the software is not there, and the code is not there. Like, nothing's there. Whereas in open source, yeah, the maintainer gets hit by a bus, but like, someone can pick it up, and it's a sad thing to happen. But like, the code
Yep.
code
Right.
doesn't care, right? It's on the
Right.
server somewhere, and it's your call if you're gonna take the code and maintain it, or perhaps just fork it and use it internally. You don't have to even maintain it publicly, but you're allowed to do that. And what we've been saying about open source a lot is that literally the only difference between proprietary and open source software is, like, open source software, you get the code, and you can, of course, and you can do with the code whatever the license allows you to, and that's the only difference. There are implications, of course, like, different things tend to happen to open source software versus proprietary software, but it's not that doing open source implies doing everything else that people think you should do when you're doing open source, and vice versa. Doing proprietary stuff doesn't mean you're a big evil corporation, right? it's
Right. Yeah.
it, it,
Exactly.
it's all kind of related to how people behave, but
Yeah.
the
It's like a
code
spectrum, right?
itself is
I mean,
just
it's
code, right?
yeah. Yeah. Hmm. Interesting. Okay. Well, I mean, let's talk a little bit about the. I mean, so we talked last time about Renode. Can you remind people what Renode is?
Sure, it's a simulation framework, an open source, of course, simulation framework that especially works very well in the context of simulating IoT systems. We can do multi-node systems. Typically, like, we have a lot of Cortex-M support in the ARM world, and of course, we have a lot of RISC-V support, both 32 and 64-bit, and you can go up to fairly big devices running Linux and build networks. And increasingly, also, we've been used in, like, prototyping of new SoCs, new platforms, because of course you can just build a simulation model, and we have the ability to trace and debug and measure different things, and so people have been also taking it up in this kind of pre-silicon development context. But like,
Mm,
much of our use is also in just, I do have a dev board, but the dev board is just hard to put in a CI on a server, so
yeah.
instead I'm using simulation to kind of automate my processes easier.
Mm-hmm. Yep. Yeah. This is something we actually talked about in the last episode as well, about like continuous integration, continuous deployment, that sort of thing, and Renode being a part of it, where you're not actually pushing maybe a new piece of firmware or software to a board, you're pushing it to a simulation. That's that kind of idea, right?
Yep.
Yeah, that's cool. So then let's talk a little bit about so we kind of touched on the FPGA stuff last time, but obviously there's more and more happening in the past 6 months, and continuing on in the open source silicon space and the tool chains, FPGAs and ASICs. So where is that stuff moving?
Oh, that's kind of moving on pretty nicely. I mean, there's many things. First up is, generally speaking, yeah, RISC-V has established itself as a very important player and one of the top choices, for new designs. If you need to build something with a core in it, you're probably going to use a RISC-V, especially in the FPGA. Of course, that's trivial because there's just so many things you can grab and run on a $50 board. But also in ASICs in silicon, kind of more and more people they come to us and say, "Hey, I want to adopt RISC-V for our next product. Can you advise me what core implementation to use and what are the drawbacks and benefits and trade-offs?"
Right. Right. And just to remind people, RISC-V is a ISA or instruction set architecture, but then there's a bunch. I think what you're saying, Michael, is that there are a wide variety of actual implementations, like actual cores, right? So how does
Yep.
that interplay happen?
Well, I mean, different people want different things. There's different regions of the world, and everyone wants to have their own flavor of RISC-V in a sense. The ISA, the specification is common, and it's developed by a consortium who has to negotiate what kind of stuff goes in and out of the spec. But as the spec gets ratified, certain things are fairly fixed by now. So kind of you just
Yeah.
have to play along with the rules. But then the micro architectural implementation, or how many cores you're going to have, or how these cores are going to talk to each other, what kind of I/O you're going to put on a chip, all of this is up to you. So in fact, there's still a lot of variation, even though the ISA is the same.
Yeah, it's interesting to me because when I think about an open source project broadly, I usually think about large software open source projects, Ubuntu or sorry, Linux more broadly rather, and you think about these I think about them as kind of this monolithic thing, but that is very much not the case. And it really does become these because there's so much opportunity for customization. Again, just to use a Linux example, there's however many distributions that are out there. There's maybe like some strong contenders for, the center of gravity around new users using Ubuntu, others are, using, like corporate users might be in Red Hat world or CentOS or whatever. And so like how does that end up playing out in the space as well? It seems like are we in that realm where people are still figuring out the variety of different cores and combinations that are available? Is there a center of gravity yet, I guess?
I mean, there are a few at least, but apart from the centers of gravity, there's a lot of variation as well. So you can't not mention Sci-Fi, of course, who are the original people behind RISC-V that kind of came out of Berkeley and founded the company, and they of course have a big portfolio of cores and recently just released some performance-oriented cores, interesting stuff just a few days ago, and they tend to of course do quite a lot of stuff, and we work a lot with them and their customers. But having said that, Sci-Fi uses Chisel. Sci-Fi has specific, design choices that they do, a certain, set of alignments and so on. And there's plenty of other choices that other people might be inclined to use instead. We're kind of neutral in the sense that we tend to suggest whatever people feel best with, because ultimately it's going to be their design. They're going to have to live with it and continue to develop it. So some people, love Chisel, other people hate it.
Opinions and engineers. This is very weird to have opinionated engineers.
So that's kind of one of the angles, but of course there's many more. There's kind of implementation stuff. There's different kinds of processes that you can build those chips in, or research interests and stuff like this. So there's another center of gravity somewhere in more in Europe, around ETH Zurich. These guys have cores written in System Verilog, which is also a love-hate thing. Some people believe it's the only way. Other people say no, that's so 20th century. We're in this camp which says, well, both of these things are great. Like we use
Yeah,
Chisel a lot
yeah.
for doing we did a DMA core in Chisel. We did we're doing a bunch of projects in Chisel, but we're also using System Verilog for other things and kind of building tools. We have this two efforts actually. One is just supporting System Verilog better, in open source tooling for parsers and linters and formatters. That's what we're doing with Google, and kind of putting a lot of effort into this, into Chips Alliance. And this is kind of trying to enable all this code base. There's a huge code base of System Verilog stuff out there that people would still want to continue using, and you can't just throw it into a dumpster. So we're kind of enabling use of that code in open source tools by enabling the constructs of the System Verilog language, the HDL, that they're using to work in different kinds of like parsers and linters and formatters and synthesis tools. And then another effort is focused on doing UVM style verification with open source tools, because everyone keeps saying, oh, it's impossible, and we tend to say it's impossible as of yet, but we have done good progress, and if we put in more work into it, at some point you just will be able to go take UVM benchmark test benches and push them through like Verilator.
And what is UVM?
It's the universal verification methodology. It's kind of a well-established methodology to verify chips. And for those of you that don't know, building ASICs is kind of much of the work ends up being in the verification space, because if you're going to tape it out, you'd better be sure that it's working. So of course design is important, but then you spend a lot of time in testing, in a sense, right? You just have to verify that the thing you've done works in various contexts. So UVM is very often used by people that do System Verilog, and then that's not supported in open source yet. And we're kind of working to get Verilator to support this. We've just had a talk with the Chips Alliance last week, I think, where we presented the recent progress, and there's been really good progress. So we're kind of trying to tell people, look, probably the future is going to be diverse. Like there's going to be people working in Chisel, other people will be using Midgen, which is a Python-based framework and language. Other people will focus on System Verilog. There's VHDL is of course still quite popular in Europe and at IBM, I believe, and other places. So
in the military industrial complex, I believe, as well.
for example, so in general, there's just going to have to be plurality. Like, and we're okay with that, because we've seen that in software it's exactly like this. Like some people love Docker, and others are like, we have to use Kubernetes for everything, and others like, no, we've invented a new container runtime, and that's just how it works when you get a lot of engineers into one room.
That's right. I mean, so when we look at all this stuff, I mean, the variety of things that are out there, is it more that it's just kind of coming to light and it's been behind closed doors and now it's less behind closed doors? Or are these actually new platforms around this stuff as well? I mean, I know we covered some of this stuff last time, but if I'm being completely honest, some of it is so far over my head, I've forgotten some of it, Michael.
No, there's a lot of both. Like there's both stuff that's been around, just very, very niche, and nobody's heard about it. And there's just new concepts and new tools. And I think that's great, because getting people to uncover stuff that they've been working on for 20 years is an incredible thing. And Chips Alliance kind of has been involved in this kind of community building, where you get people that used to just develop something in a corner and see the value in the tool, and like think about how do we make it into something that's useful to the broader community.
One thing I'm also wondering about, though, is there still stuff behind closed doors? So if you walked into an Intel or an AMD, is there stuff and proprietary tool chains that are like not on this list, that are actually, like, because I'm a very big fan of this, and I'm in charge of scheduling guests on the Amp Hour, and we've had a lot of people in here talking about it, and I'm excited about it. That doesn't necessarily mean that represents all of reality, So how much does this represent the broader industry in terms of percentages as well? I mean, are the Intels of the world using something completely different that we're not even including on this list in terms of verification and that sort of thing?
It depends, like, because in different areas it's a bit different, but in general you can think of it as there is a lot of stuff behind closed doors that could potentially be open sourced, for example. And we are talking to different people, different big companies, explaining the benefits of doing so. And it's hit or miss, right? It depends on who you talk to and how they present the benefits and how afraid they are of the consequences of opening up some things. But
sure. Well, I remember I had a particular interaction with someone about this stuff. I was talking to someone about doing, so they were at a large lab and designing hardware there, and they were using like ultra sync ultra scale chips, and I had mentioned like, oh, have you looked at like the open toolchain things? And he just kind of looks at me, he's like, I mean, there's nothing there, Chris. I can't do that. Like it's just not there yet. And so it is these, just to maybe it's a little bit of a splash of cold water, but like there are certain areas and certain realms where we're just not in yet. It's just
Of
this is not.
course.
Yeah.
Yeah, it's like the work to be done vastly outweighs the work that has been done so far, and
Yeah.
that's not just FPGA toolchains or something. It's everywhere in the world. If you look at it, most of the stuff out there is just closed. You don't understand how it works. Nobody describes it to you, and it's nobody's fault. It's just how it turned out. But
Yeah. To use that example again, it's just like he had a certain specification, right? He needed to use something that had a gigundous FPGA with some, hard cores in there and stuff like that. Okay, that means you have pretty much two choices. And then it's like, all right, how do I write software for this thing? Well, you get what you get what you get. It's like, you can't just turn around and like use something smaller because of the hardware
yeah,
requirements, and you aren't going to go and right, try and blow up a tool chain when you have a deadline. So like that's when it really becomes difficult, I think.
and it's a struggle. Like we basically want to approach it from different angles. Is that you
Hmm.
have to remember that the tools are super exciting and really important, and we want to change this. But I don't think we'll be able to change that without at least some degree of cooperation with the vendors. But
Totally.
there's also the IPs, right? There's also the platforms, the hardware, and we're trying to work on all of these levels. So the reason why we're spitting out, open source hardware boards for different kinds of FPGAs is that if you show people it's possible in different areas and you like chip away at this block, you
Yeah.
eventually
Right.
get to the part where it's just the toolchain, like there's nothing else,
That's right. Yeah.
and it starts like you start seeing the problem because the problem is typically convoluted. Like you get a tool chain and there's like IP cores that you get for free
Hmm.
bundled there with,
Yeah.
and everyone's kind of a bit lazy, just like I am, right? Like even in my
Yeah.
in my
Yeah.
team, right? Someone comes over and says, "I want this FPGA project," right? We have customers building FPGA stuff, and if you tell them, "Hey, building this from scratch is twice the work that just grabbing Xilinx IP," well, obviously, for many people, the economics are going to be simple,
That's right.
right? Like,
Yeah.
let's just
Yeah.
grab the stuff that's available off the shelf and just is there. So, what you have to do is like figure out where is open source already good enough or almost good enough to be immediately used in practice. And we've been able, especially in the past few months, to do a bunch of projects where we've been able to show how open source stuff can outperform even the
That's
proprietary
great.
stuff.
Yeah. Yeah.
And it's islands, right? But you kind of over time you merge those islands and you push more and more. And risk 5, for example, has been instrumental because with risk 5, like whenever we've been able to achieve really incredible performance results with cores like vectors 5 and FPGA, where you can put a multi-core Linux capable sock into your FPGA. And I'm not talking about like a huge VU19 FPGA. I'm talking about something that has 35k LUTs or less,
Got it.
right? Like
Like the high end of a micro semi. Or God, that's an old
no,
name. Uh,
I think that's the low end right now. Like the
is it
micro
okay?
semi thing goes to like the polar fires beat up to, I don't know,
Oh,
I
that's
don't
true.
want to say
Yeah.
the wrong thing, but they have hundreds of KLUTs, right? So I'm talking fairly small commodity FPGAs that you can buy on $100 dev
Got
board,
it. Yeah. Yeah.
and
Yeah.
that can run Linux and Doom, and and people are shocked because like they're like, oh, we thought that was explicitly impossible, and you show them no, actually, you could fly to the moon
Yeah.
on
Right.
this kind
Right.
of hardware before. Why wouldn't you be able to run Linux on this? And of course, it's the result of a lot of different pieces coming together. But that's exactly the progress. When you do incremental progress in different areas, over time you take a step back and you see you've doubled the performance or you're
Right.
vastly
Yeah.
improved the ecosystem. So that's kind of what we're trying to achieve, like playing at it from different angles, a little bit, toolchain work here, a lot of IP work. We do a lot of open source FPGA IP stuff, methodologies, flows. Perhaps if you can't do open source place and route, you can do open source synthesis with something like Yosis. So there's many ways you can kind of approach this problem. But ultimately, of course, the problem is pretty complex and it's
Yeah.
not going away anytime soon.
I have a example that is not actually a FPGA example. It's a firmware example, but it's kind of the same thing, although it's kind of also a bad example given recent news. But like one thing, like, so Nordic put their Bluetooth stack into Zephyr, which is another thing you guys work on. And the bad news is that there was a security vulnerability recently found, but that's neither here nor there. But like before, it was like you have the binary blob and it's tested, and that also could have had a vulnerability as well, but you don't know that. But then you could start to actually, when it becomes more open, you can actually like whittle away the things you do or don't need, right? So in terms of space, in terms of speed, you can start to optimize things, and you have visibility into it. I imagine that same kind of thing is happening in the FPGA space of just like you have more visibility into the code, into what you need, and it becomes more piecewise instead of like being handed a blob or just a block of code that you can use. You can kind of pick and choose, and it's a tighter integration. Is that a good example or no?
Absolutely. I mean, the part of security vulnerability, we should definitely go back and replay the part when you said there might have been a vulnerability, you just didn't know about it
That's right. Yeah,
in
I
a
mean, yeah, I
proprietary.
mean,
So
right.
in fact, like that's the whole point of open source is that yes, vulnerabilities are easier to expose, but like that's the whole point. It doesn't make the vulnerabilities go
Yeah, right,
away.
right.
It just puts them in plain sight, which sometimes is detrimental, of course, but like that's only because you haven't been doing your security analysis well enough. And I think that you're correct in this analysis. Like you can start tweaking things in various different ways that just they wouldn't come to mind to the vendor
Right,
or
right.
some kind of, especially a lot of the FPGA space you have to remember is like people buying various little IP cores from various tiny vendors, right?
Right.
And
Right. Yeah. Yeah. It is surprising sometimes you're handing over 10 grand for like some code, and they say it works, but like, do you know it works?
it's probably tested, and so I'm not saying it's bad per se, but like it definitely hasn't been optimized for each and every use case out there, and
Yeah.
it
Right.
definitely
Right.
hasn't
Right.
been tailored for you. It's just like you're getting a stock black box, and I'm not
Right.
saying it's unreasonable to expect you to be paid for something you've put in a lot of work into.
Hmm.
It is just like I think personally this model will be going away, and open
Yeah.
source will just take over because it makes sense where you have this building block type of system, right? Where literally you can kind of switch things to other things, and they interface to each other over kind of almost physical, APIs. It almost feels like it's even a better example of why things should be open source than software is, because
Yeah.
like a software doesn't have to have an API. You can write software that's like is very hard to integrate with, and you just have to rewrite it to make it integrable with other stuff. For IP cores, I mean, literally they have buses and there's interfaces like AXI that you connect those over those buses, and so that's what we've been showing with Renode as well. You can kind of plug it into that conversation where we're showing, look, the SoC is a bunch of things sitting on a bus and talking to each other, and there's no magic. Like, sure, there's some magic internally in the hardware in terms of the microarchitectural implementation of things, but on the top level for a software engineer, like whether it's this UART or that UART, like it's just literally a difference of the registers are different, the memory map is different, but it more or less works the same. And all of these things are kind of synonymous, and you should be able to think about them in a much more like, should I use this or that? And you should be thinking about it from like, what do I need for my software, for my end use case perspective? What you end up doing instead very often is what's available in the market, and you take it and you try
Yeah.
to map it
Right.
onto your application.
Right.
Then
Writing
you're
wrappers and
frustrated.
yeah.
Then
Yeah.
you're frustrated because like the hardware you need actually doesn't exist at all, or perhaps there's just one thing that fits your bill, and then of course there's the chip shortage right now, so it turns out that the thing
I
you
haven't heard about
wanted.
that.
So it's kind of, actually the chip shortage has revealed a lot of the ridiculousness of
Mm,
hardware.
yeah.
As long as everything is available, you can get by. Like you just go and you're like, oh, okay, that's not possible. That's not, but this one works. But if most of these things are not available up front and you have to wait like a year to get them, you realize that not only is it bad, it's also not there, and
Yeah.
and
Yeah.
and and those things pile up. And I think software people are starting to realize that, hey, we'd like to be more in control of the hardware that we're getting, because then like we could dictate whatever gets manufactured. And of course, like in theory, that's the case, because I'm not saying that the semiconductor is not listening to software engineers, but they're typically listening to them through, 10 layers of corporate structure, and
Sure.
possibly they're also listening, just to a few big guys, but they're not necessarily listening to thousands of voices out there who might have something interesting to say. And open source will not change that like in one day, right? You will still have a lot of confusion and frustration, but the frustration, what I like about open source is that you can take your frustration and turn it into something productive. You can take the stuff and improve it.
Yeah, it does sound like have taking action in a situation where there is no control. Yeah, I'm not completely sure. I mean, like abstraction just to solve a problem like this is maybe not something I'd necessarily recommend, right? Like if you can't get a certain chip and you're like, well, I could just switch to another chip, and but I just need to go and write a huge framework to make everything look exactly the same to my software. I'm not sure I completely agree with that as a solution, but I do agree with it more broadly of like, but the porting would become a lot easier if it was from the beginning, a more abstracted type of interface, and then it just becomes a moving some parts around at the end and re-verifying.
Yeah, and believe it or not, it's already quite abstract, and it should be quite prone to this. And much of the movement around making it stay like it is right now, like making IP cores close and so on, this is just a legacy mindset. This is just inertia. But like, there's nothing other than, there's nobody that has big enough interest in making these things open that would just give it a strong enough push. and
Mm.
and so we're trying to, be one of those forces where we just kind of try to give it a much stronger push than we normally would, because ultimately we think that open source will really transform the space, because you'll be able to just go and build your thing without asking anyone questions, without signing NDAs, without getting frustrated. And that means FPGAs will go into many more places. FPGAs will be much more
Yeah.
easy to use, and less frustrating for people. And overall, I think it's going to be a huge benefit to the FPGA vendors themselves.
Sure. So one thing I want to get back to too is the idea, kind of like the mindset shift as well of that idea. Just to go back to the buying of IP versus kind of using IP that's out there or test whatever. But it does seem like implicit in all that is a testing mindset, and this is something I kind of brought up last episode. I was kind of marveling at Node and how all these different independent interdependencies can work, and it really is only possible because it's all tested in the first place. Pulling in 1,000 different submodules and getting everything to work like that. There has to be testing there. Whereas it feels like if you're buying an IP module, it's like you're basically kind of handing off that responsibility. You're saying, well, I paid you all this money. You have to make sure it does exactly what I say it does. You need to hand me traces that show that it's doing what I asked you to do. But now it's like you're pulling now an open source module off the shelf and you're saying, actually, does it work in my specific scenario? Does it work in my chip, in my design? And does it work how I want it to work?
Yep. And you can, test it much more easily yourself, and you can pay someone to test it. And like, it doesn't mean that the thing that you're going to get is always going to be of superior quality than whatever a proprietary IP core would be. But at least you get a fair chance at checking it yourself if you need to, and or just finding someone to help you. And we offer those kind of services, but like, it's never exclusive in open source, right? You have choice. You don't like one vendor, you go to someone else. In this proprietary landscape, the challenge becomes that it effectively becomes an oligopoly, where it's just very hard to break through, because most of the pie is already eaten. Nobody is interested in growing the pie, because like, they own the pie. But I think that what open source IP will do, it'll just grow the pie. It won't necessarily make traditional vendors go away. They'll have to change a little bit, but there's always going to be niche applications and different kinds of people that just prefer to pay and not have the problem. What we're typically as Micro, what we're looking for is customers who actually want to have the problem. Like, they want to own their stack a bit more. They want to be more vertically integrated.
Right. Yep.
They're
Yep.
okay with learning how to do development in order to be able to sustainably kind of improve things without having to rely on third parties, or exclusively rely on third parties. We are a third party too, and people rely on
Sure.
us a lot.
Right. But you also hand the code back at the end of the
Yes.
engagement. You're like, well, yeah, you don't like our services. Go ahead and do it yourself or hand it to someone else or whatever. Right.
And
So
most often it's not like someone doesn't like the service, it's more like people want to take it over internally, for example. It does
right.
happen
Yeah,
because
that's a big one. Yep.
you're
Yep.
developing it for years, and it's gone to the point where most of the hard heavy lifting has been done, and there's this occasional tweak and a comma that needs to be moved from place A to place B.
Right.
It's okay for you to take it over and do it internally. It's actually probably the best way to do it, because the overhead of telling someone somewhere else to do it for you is just too big. But of course, a lot of our projects end up being very, very long running, because as people get to start building their own things, they realize there's just so much more they could build, and they stay with us for a very long time. But we do
Yeah.
have those
Yeah.
kind of drive-by customers, right? Like they build a product and the product's finished and they take it over and disappear, and that's also fine.
Right. You still see the commit messages from them, so they're they're doing something there or something like that, right?
Yeah, or even they come back after 3 years and say, "Hey, we're building next gen now." That's even cooler.
Right. That's good too. I mean, so if someone was okay, so someone let's contrive an example here if you don't mind, because I do love doing that. If someone was completely disenchanted from say they're like doing a FPGA security camera, they've gone through a previous channel and it's completely closed source, and now they're like ready to be. They're like, all right, I'm picking up what Michael's putting down. I'm ready to do this. Like, what is the most open path right now to do this sort of thing? I mean, if they were ready to go all in, what would be the most open scenario that you could think of? Because one thing I want to type, we've been talking about open source in the abstract for the past hour, and we obviously people can go check out the open source.antmicro.com, but like piecing it all together in terms of putting hardware and firmware and software and maybe even stuff all the way up to the cloud in line. What does that look like? I mean, what is the most open example you've seen?
Funnily enough, we've actually had customers that asked the same question, right?
Oh,
And they're
really?
like,
Interesting.
we want to build like a fully open source flow from beginning to end. How do we do that? And what kind of platform do we need to use, and so on? It depends on what you want to build, of course. I can talk about this example of it's a security focused company, like
No, I
with
said a security camera. It's just I'm just like I said, it's just a contrived
okay,
example, right? So it's a
okay. Let's
camera.
take the
It's
camera.
got
Let's take the
network
camera. It's
connectivity. Yeah, it wants
yeah,
some kind
sure.
of smarts on it for doing like human detection in a space, right?
Yep. So basically, first of all, open source like Ethernet IP cores or open source PCI Express and so on. These exist. These are being used. We are implementing them in projects. So kind of that part is actually pretty well sorted out.
Okay. All right.
Probably kind of if you really wanted to go full open source, if you're gonna wanting to use an open source tool chain, you might grab a 7 series FPGA, and that's kind of part of the
Okay.
Simpliflow project.
Sure.
You could also use a Lattice, an ACP5 or the Crosslink NX. Actually, we're working with Dave Shah right now to also kind of open up the tools for that platform. So
Sorry, what was that last one?
Crosslink NX, it's a like fairly new
Crosslink.
FPGA from
Oh,
Lattice.
cool. Okay.
And those kind of platforms, this family of platforms, you'd get pretty decent coverage of open source tooling. Again,
Yeah.
depends on
Right.
what you want to do, really. But
Well, we've had people on the show before, yourself included, talking about all of the up and down the tool chain. We have Claire on here. We've had Peter talking about stuff. I mean, just a lot of different. Tim has been on a couple times talking about it. So people
yeah,
can go and listen to all the various episodes about the open source toolchain
yeah.
stuff for FPGAs, and we
And it's
like that
improving,
around here.
right? So if they
Yeah,
listen
right,
to
right, right.
something that was being talked about some time ago, the chances are things are better now. Then you'd go and basically boards. Also, there exist open source hardware boards. If you want to have dev kit that's open source, we have some dev kits, and we've been kind of pushing out a bunch of open source hardware. But of course, especially I think for the Lattice parts, there's quite a bunch of hardware available right now.
Hmm. And are you actually manufacturing and selling that yourself, or is it just like it's under your brand and someone else is making it?
So in the FPGA space, I don't believe we're selling any, or even someone selling any of our stuff yet, right? We're doing this, as you know, for the NVIDIA Jetson board that we've designed, kind of
Cool.
working
Yep.
with Capable Robot, and that one is being sold and actually selling very well and getting into a lot of projects. But we'll probably do that with FPGA boards as well.
And that's Chris Osterwood as well, past guest of the
Yes.
show. Yeah.
Yeah, okay, you've had Chris, of course. So, so basically, for FPGA boards, we don't do that yet, but like I think we should. So it's an open topic. But
Okay. All right. But I mean, the designs are out there too, so people could go and fork those
of
and
course, yeah,
manufacture them
yeah.
themselves as well. So again, if they want to do completely open, they could go all the way down to the sending files over to an assembler and be like, "Hey, let's do this."
And then, in terms of if I was doing a security camera, I'd probably go either I'd use something like a Zinc, but then if you really want to stay with a pure FPGA, RISC-V would be your
Mm-hmm.
choice. And
Sure.
then for RISC-V, I'd probably go with Vex RISC-V, which is like our canonical RISC-V implementation that we're using
Mm-hmm.
from Charles Pepon. And Vex RISC-V is really, really performant and quite small, so it doesn't really take up a lot of your FPGA space. You probably wouldn't necessarily need to put Linux in the camera unless you wanted. Like depends on what kind of camera you're building.
Sure. Let's say why not, right?
Then you could, right? Like
Yeah.
you can do that, and then
Yeah.
you'd have, if you want to output the data over, say, Ethernet or something, you could grab LiteX or something to output that data. You need RAM, but like we're working a lot with LightDRAM, which is an open source DRAM controller, and
Mm-hmm.
implementing support for various parts and testing it with various hardware platforms. So you could interface with RAM using an open source controller, and so on and so on.
And you said there's an Ethernet core as well, like then. So an Ethernet
Exactly.
core is that the everything but the PHY kind of idea?
Yeah. So basically, a lot of the time you end up kind of some part of it ends up being some little Xilinx or lattice wrapper here
Uh
and
huh.
there,
Uh huh.
but you can kind of all of the digital logic is typically open and shared between platforms, because that's one other thing with these things. As you create open source IP cores, you realize, well, you could actually reuse a lot of this across different vendors, and vendors don't do that because of course each of them wants you to stay on their
Right. Right.
platform.
Lock in.
But for the IP cores that you're doing, you realize, okay, like actually it's very useful, because then you can start comparing and perhaps
That's
like
right.
recommending things to customers that they really need, right? Like if you had this apples to apples comparison ability
Right.
between
Right.
different platforms, you would just be able to kind of help people do whatever needs to be
Yeah.
done.
And you would actually push sales, right? So
I
you
think
would
so.
be able to go
Yeah.
to sales and you'd be say like they'd come back to you and say, why didn't we win this socket? And you'd say, well, I compared the lattice part and the Xilinx part, and the Xilinx part had X, and I compared it to the lattice part, and it didn't have X, and you didn't win that socket. And then there's like a money anchor for why they should take that back up the chain and maybe actually do that, right? And that's when I feel like the rubber hits the road, is like a very realistic, like, we lost because of this feature missing, and then that gets put into a roadmap, and that ends up changing stuff down the line.
Yeah. Or even like the funny thing is, most of the time, what's missing is just better IP. Like sure,
Sure,
a
yeah, yeah.
better class of PGA with more IO or faster IO or something. This is very, very important, and it's good that you can kind of help vendors put stuff on their roadmap that's
Yeah.
important.
Yeah, it is always interesting when they all say like the the LUTs. The LUT is such a soft term. I mean, I know that it actually represents something, but a LUT from Xilinx is different than a LUT from Lattice or Altera or who, you know what I mean? Like the actual comparison, it's like these soft comparisons. Well, this isn't quite 35,000 is actually 30,000 on our platform. It's better. It's like, oh, okay, well, I need to actually compare these things. I need to make an engineering decision.
Absolutely. And the truth is that people are confused. Like in the end, people go away. People don't go into FPGA design. People get frustrated and change jobs. They go into front end design because how frustrated can you get before?
You see
So
that, Xilinx? This is how we get more JavaScript developers. Damn it!
nothing hates JavaScript developers. So in the sense, I do believe that actually it would be a win-win situation for everyone if we had like a shared ecosystem of IP cores and tools, because that would mean you could just build stuff in FPGAs more easily. And because we do get a lot of customers who come and say, well, we could use like an NVIDIA Jetson or an FPGA. And FPGAs are kind of complex and like nobody likes them.
Right,
And
right. Look at these dev kits that we can get from Jetson, and just have all
yeah,
the SDK ready to go, and I just use the example, and it looks like my example. And it's like, oh, yeah, that's actually pretty compelling. Yeah.
just a hint.
Yeah,
Hopefully someone's
right.
listening.
Yeah, it becomes like an application thing, right? I mean, and like I don't know, it runs very quickly into like money constraints, right? Of I can't spend tons and tons and tons of time and resources for something that might not work. I have to, it's a development project, it's not a research project, and it's like, but as the FPGA stuff increases, it becomes more of just a development project. It's turning it, turning the crank, turning the next thing to make, to pull in that Ethernet core, pull in that PCIe bus or whatever.
And in terms of this open source camera project that you mentioned, right?
Oh yeah, right.
And then there's lots of tools around, simulation. You just use Verilator, and
Sure.
you can use Renode for the software development on the RISC-V core. We have,
Mm-hmm.
support for all the kind of major RISC-V implementations, and much of the soft IP, that the kind of leading
Yeah.
class. So
Well, let's tie that together too. So like, so now, okay, so I'm talking to my software engineer. They're writing code. It's being simulated on Renode, right? I go and push a change to the FPGA stuff that gets pushed to Renode so that they can see the change and test that, right? But then that also gets pushed down the stack so that it can be tested against what will eventually get pushed out as a firmware package to the camera. Is that right?
yeah, you can do it like this. So in FPGA development, of course, when you change your building blocks a lot, then if you model that in Renode, you'd have to kind of change the models too. Except, of course, you can co-simulate with Verilator, so that's one way, and then you just take the HDL, the code for the IP directly, and you simulate it in Verilator, and you just plug it in. How we typically end up doing this is we partition the design into a slowly changing part, like your core, the fixed IO stuff that like doesn't really do much, like Ethernet might be an example. It's
Yeah.
typically
Don't
you're
don't
not
change that
really
too often, guys.
tweaking that much, right? But
Right.
say
Yeah.
you're interfacing into different cameras, so you're changing your MIPI CSI core a lot, and that part you can potentially just simulate in Verilator and plug it into the rest of the system. And some of these things are simpler to do, some of them are more tricky, but in general, partitioning is your friend. You
Got
can
it.
kind of
Yeah.
co-simulate both between something like Renode and Verilator. You can also co-simulate between Renode and physical hardware. That's another way you can partition a design. We've
Mm-hmm.
done some cool projects where we'd use extremely large, FPGAs, extremely large designs, and helped some big clients, integrate fairly complicated building blocks by just, doing the right partitioning.
Hmm. Does that then cut down on like compile time, simulation
Yes,
times,
yeah,
build times, that kind
development
of thing?
time. That's
Yeah.
that's key because in FPGAs the development time is ridiculous. Typically, like you do something and then you have an hour to where you don't know what to do with yourself.
Another XKCD comic there, right? Of the codes compiling.
Yes, yeah, and that's true in FPGA development, right? It's no longer so true very often in software because
Mm.
although we do a lot, I don't know, Android development is as well kind of frustrating sometimes because building
Mm-hmm.
Android from scratch is like again an hour or more. But in FPGAs, it's especially visible because as you go to any practical design, I'm not talking about like toys and small things, but if you're building some kind of a streaming device or like a security camera or something, very quickly you'll hit fairly long compile times, and if you want to do some kind of tests against various scenarios, each and every piece of this will make your entire development cycle longer. In some sense, there's no going away from it, but
I have a very long ago example of this where I used to work on Vertex 4, so a long time ago. This is 2004 or so. But we would be changing things in like it was like a DSP generator type of thing that was in there, and it'd be 6 hours, right? It would literally be 6 hours to build on the computers we had, and so it was like, well, you get it first thing in the morning, you give it a shot from the night you test the thing you did the night before. You have about 2 hours to figure out if you want to make any changes. You do a build, and then you test it again when you get home before you go home, and it's like yeah, that's the whole day. You get 2 builds a day, and that's it. And so if you can cut
yeah,
down on that, you start to get more iteration cycles, and you can do better like that.
that actually ties very well to a bunch of things. And one of the things that we didn't mention much so far is like our involvement in kind of cloud development, and how do you accelerate workflows using just disposable compute power. We're working with Google Cloud, and generally speaking, we're helping figure out ways to accelerate those processes like design, development, test for FPGAs, for ASICs in the cloud, partitioning those into smaller chunks, running them potentially in a parallel setup. And this is kind of a very promising area because, of course, normally this is not how this kind of development has been done, and the IDEs and the tools used are typically like monolithical, and you just put them on a PC and you just buy a very
That's
beefy
right.
PC.
Yeah. Right. Yeah. The best you can do is buy a bigger PC, right?
But increasingly, people realize, okay, you could actually just scale it up and use a big server, and also use it just for a while. You don't have to use it all the time. And open source kind of leans very well into making things more distributed, because you can experiment with how the toolchains are built, and perhaps see some opportunity in partitioning designs into smaller chunks. And or for example, one interesting approach is getting tools to simultaneously, for example, place and route a design with various seeds, right, and see what happens, and the
Yeah.
best design wins, and stuff like that. And
Right. It becomes like evolutionary at that point, right? Instead of like one cycle, now you have lots and lots of family or branches on the tree.
so there's a lot of work in that area. We're kind of actively involved. We've been building, kind of integrating stuff with GitHub and Google Cloud, building, custom GitHub runners. Because what ends up happening is that, since most of the time the CI frameworks and the cloud providers, all of this is typically used with software where the build times are not as long,
Yep. Yep.
and the requirements might be like, some of the tools have ridiculous like RAM requirements, and the default
Right.
machines just don't have that.
Right.
So you have to go and implement, support for your own machines that can sustain those loads, perhaps from the point of view of RAM, or perhaps you want to kind of measure some additional metrics. And then we've been building these kind of custom setups where you're using GitHub. So like it's a and that's been done in the Simplify context, but also in other contexts, also for EDA stuff, where you're using GitHub as a platform, but in reality you're running your own servers, or perhaps Google Cloud servers, as the compute power provider, and then you can do whatever you want, and the machines can be however beefy you want them to be.
Is this an open source project or is this for a particular client that stayed closed?
No, parts of it are open source, and like
Hmm.
it's a work in progress, right? So it's
Oh,
not.
sure. I'm just wondering. I'm sure someone's listening. They're like, "Oh my god, I need that." So, like, how
No,
would someone
absolutely.
find out
And
more about that?
and I think that we're just kind of getting started. It's like people have seen the opportunity, but like I don't think we have yet exploited everything that there is to improve those workflows, and especially for
Sure.
for chip design. These are really massive and problematic projects, which are just waiting to be optimized. Google has been showing some incredible results with using AI to improve the design process, but again, it's probably just scratching the surface, because this has been such a manual process and such a resource intensive process that people have just lost the forest for the trees.
Yeah. Yeah. Google just announced that or they just published that paper, right? One of the AI researchers was doing like a chip design using AI, right?
Yep. I think they even were multiple papers, but it's just getting better. And as long as you can get superhuman results in fairly limited time, that's when things start getting interesting, because you can then experiment with lots and lots and lots of runs and different kinds of AI approaches and just improve it. Whereas, I mean, you can teach a human designer to be better, but like it's going to take years for them to have a measurable improvement. But for computers, of course, we can just go and tweak things all the time. So yeah, I think the cloud is a huge opportunity, and we're doing a lot of work. Also, kind of interestingly, it ties also some other areas of our activity where we do over the year update stuff, or like just remote device management, working with a bunch of big clients there. And it,
Mm,
it, it seems to be unrelated, but like as you take it apart, you realize, oh, the problems are kind of similar in many ways, where you try to abstract out the physicality. For example, for AGI devices, like you want to be able to test them in something like Renode, for example. You want to partition the problems. You want to use open source, right? That's what you ask for. Is this open source? Yeah, I mean,
sure. Yeah.
if it wasn't, then like cloud is all great, but if just how to do this, and they have to come to you for you to explain it to them, you're always going to be a bottleneck. It's better to do things that are open, and then some people will just experiment and go away, and some people will experiment and fail, but there will be a large group of people that will come to you, and they'll already have tried this stuff, and they want more of it, and that's the kind of customers that typically are the best ones to work with.
Yeah. Yeah. I think the fear that like there's going to be the work runs out is a bit unfounded, because there's a whole lot of stuff to do. And I think increasingly too, I mean, like just the complexity of the things that you've been talking about in this hour have been so crazy, so over the top, in terms of like just thinking about how many people it would have taken by themselves in the past. And now it's because it's been parallelized, and because there's open source software on top of it, and there's more capabilities, that one person can do a lot more with software.
Yep.
Awesome. Well, Michael, what else should people know about? I mean, obviously there's a ton of stuff going on with Ant Micro. How could people keep in touch about what is new, and kind of keep an eye on what Ant Micro is doing?
I think the best way to do that is the blog, of course, and just looking at the blog notes we're pushing out. We tend to co-promote them, of course, with like RISC-V and Chips and Zephyr. But of course, various things go into various outlets. The best way to follow us as such is of course, our own blog and the open source portal since some time. So from things worth mentioning, perhaps we won't have enough time to kind of talk about them in detail, but just to put out there, since we're kind of invested so much right now into kind of making things work in the cloud and kind of scaling up stuff, we're also building some of our own server infrastructure. We have some projects called like Scale Runner and Scale Node. As the name implies, the Scale Node is like originally a Raspberry Pi compute module for baseboard for like server room use, and basically you can put I think 18 of those in a single U rack, right? And then you can just scale resources very quickly. It's a like Power over Ethernet single compute module per one board, and then you just can have many of those. And we're building this cluster approach because we want to, give our developers as well as our customers, as much compute power as they need. So the scale node is one project, but then since we'd already built that board, one other project we've been involved with is the ARV SOM, which is effectively a RISC-V SOM based on this, Star 5 7110. Sorry, so now it's 7100. It's going to be 710 in the next generation. This is the chip that's used on the Beagle 5 Starlight board.
Oh, cool. Okay.
Yeah, so kind of you have choice. You can use Raspberry Pi, but you can also put in a module that's kind of compatible with the Raspberry Pi compute module and run it in your server room. And these are, of course, open source designs that we're building, or we have built in some cases, or we're building. And so not something you can buy off the shelf at this point, but we are typically, when we do these things, typically people approach us and say, hey, we'd like to figure out a way to kind of scale it up and make it work for us and so on. So definitely looking forward to that getting traction and moving faster.
Yeah, that's cool.
Yeah, it's pretty exciting. And when we're in the server room, there's also a project called DCSCM, and this one is it's called Board Management Controller, BMC board that fulfills this kind of standard developed by, I believe, Microsoft and Facebook primarily for just managing servers. You have this slot in the server. You put your board in there, and the board kind of manages the server. And the board typically has been just hard silicon, an ASIC. But many people simultaneously, like Open Power, Tim, ourselves, like came up with this idea: what if you could just put an FPGA there and make it much more configurable and secure and transparent, because you know what's going on in the FPGA. You put an open source core in it, and open source I/O peripherals. And so yeah, we have this project called LibreBMC that's run by the Open Power Foundation, where we're developing this entire platform. And so we've built the hardware board. It's also open source, of course. Now bringing that up, and the aim is to create a completely open source BMC, so that all those big companies that use this standard can have a reference design for fully open source, transparent, FPGA based BMC. And then it's also a great use case for SymbiFlow and stuff like that.
Yeah,
Great
right.
example of how it can be useful in like very practical and mass market also use cases, right? Because it's not a niche thing. It's a huge standard driven by, I think, OCP, Open Compute Project.
Yeah, that's the Facebook thing you're talking about, the Facebook server, or is it someone else?
Well, it's not just Facebook,
It's
right?
not just Facebook, but
I
that's
think it
that's
was
sorry. That's how I
started by
first heard
them,
about it.
but
Yeah, I think that's
yeah.
yeah, right. Yeah. Yeah. And it started with like a power standard, I think, and then it's grown from there, I believe.
Yeah, it's grown tremendously. It's actually a huge organization.
Yeah. Yeah. I mean, it's a great example. I mean, I think it's a great example of, it's a hardware space, it's a open source thing. There's not like a ton. I mean, yeah, there are companies that benefit from having some kind of prowess in hardware and like being able to make a better data center. But I feel like the growth is just so fast that it's like they kind of just threw their hands up and like, look, we're all going to be growing. We might as well do a little bit of it together, and we'll customize where we see the true value. Right? And it might not be in the power system. It might be in the custom silicon or whatever we decide to put on the server boards or the HVAC system or the interface networking type stuff. But some of it is not. The stuff that is the plumbing. Why not make that common? And it
And
feels
that
like
is
that's
that
yeah
is absolutely what happened. I mean,
yeah
it's like there's so much opportunity. It's not sensible to be wasting your time protecting stuff that's not
yeah
really key.
right yep
Just cooperate around that and
mm-hmm.
focus on the stuff that you think is key.
Yep. Yeah, right. And that has borne itself out in software a lot as well. That we see that all the time in software, and now it's coming to the hardware space more and more.
Yeah. So kind of, I could talk more, of
So,
course, about some of the Renode related updates, or we've been doing some interesting stuff around Rowhammer research. So kind of Rowhammer being a security vulnerability and RAM memory, and that's again using the open source controller. Again, it has its own open hardware platform called just LPDDR4 tester. I know it's not a very original name.
yeah, yeah. You guys need to hire like just a name maker.
Typically, that's me, so
Okay.
I failed
Well,
here. But
well, it's all right.
anyway, the point is, this Rowhammer tester. It's like an entire framework for doing research that normally that would be done behind closed doors, right?
Yeah. Right.
It's kind of, it's security. It feels like you should kind of protect the secret of the fact that
Right. Don't let
this.
don't let it out until it's fixed, sort of thing.
The problem is that that always leaks, right? And you kind
Mm-hmm.
of
Yep.
at the worst possible time. And doing this kind of research in the open with together with Google, that has been a nice change, because we've become members of Gielda consortium to participate in this work, and we've kind of managed to convince them that this platform and this methodology is like a good one that should be used more in this consortium. We're encouraging all those players to transparently cooperate, because they're not able to find and fix all the vulnerabilities by themselves. They can use the help of people like Google or ourselves to just do more digging. And the way you
Mm-hmm.
can do more digging is using open source stuff. We have being able to tweak your controller means that you can fiddle around with what kind of stuff triggers a problem much more easily than you would be able to do if you just had like an SOC where you don't even like directly control the controller, right? Like it's just there and it works in a certain way, versus an FPGA, because this is a Kintex 7 board, right? It's an FPGA board that we're using there, and we put the controller in the FPGA and we talk to it and we tell it, hey, can you kind of attack those rows in this way?
Mm.
And Google actually managed to discover new types of vulnerabilities in existing
Yeah.
memories that are supposedly protected against Rowhammer, which is, of course, unfortunately not the case. And this sounds scary, but it's better that we're finding it.
That's right. Right. Then it's like undisclosed, and it's the NSA is just using it.
Yes, kind of.
Yeah.
Hopefully not. So
Right.
I
Right.
think that the Rowhammer testing framework, it's really a great example of how open source can be used in, admittedly, a little bit of a niche use case, but now we're also talking of taking this to the next level and actually taping out this controller
Mm.
specifically
Yeah.
to in a fairly new manufacturing process, so that we can show, hey, and by the way, the same open source runs in a real chip, and it's just literally the same digital logic. There has to be, of course, a bit more fun to be had around the analog part and the PHY and so on, but in general, the reusability of open source across various types of use cases is, I think, a key thing to highlight and stress, because like, even though it might feel to you that your use case doesn't warrant all this custom development, like why would you go and open source something, if you can aggregate use cases across different fields and show that there's reuse going on all the time, people start believing that perhaps it's worthwhile to put in a little brick into this building, and perhaps in the future I can benefit back from the building being complete. So
yeah, I like the idea of there being so many problems to solve, and there's being so many people that are looking to hire help, and they just keep hiring Ant Micro, and you're just being like, well, this should be open source, and I'm like, yeah, whatever. And then just eventually that keeps changing the industries bit by bit. There's just a lot of problems to solve, so why not solve them and share them?
yep.
Well, I hope other people take the hint and follow in your footsteps. Where can people find out more about Ant Micro? Where can people contact me in order to hire Ant Micro at that very reasonable 25% commission that I mentioned earlier in the show?
We'll just set up, a special mailbox for
Just
that.
Venmo's fine. Yeah. Venmo started doing Bitcoin, so I guess, whatever. But for real, how do people actually find you? That's what I really meant to say.
Our website, of course, and the contact form there, or just like write to contact@antmicro.com. It's not that hard to find us if you want to. We're on GitHub, of course, with like hundreds of projects, and but like traditionally, of course, if you need something commercial, it's best to just shoot us an email. And then, of course, we do attend various shows, and we tend to present different things that we do. I tend to go on panels, and of course, like if you have questions, just you can ask those to me. And of course, like whenever people shoot us an email and the things that they want to do make sense, we just get on a call and talk about it.
Sure. Any shows coming up that you'd recommend, or virtual, or dare I say in person?
Oh, well, I mean, not in the nearest months, unfortunately. There's one called the MiFi Virtual Summit from Microchip, where they're going to be talking about this Polar Fire SoC, and I'm on one of the panels
cool.
there.
Yep.
I think we also have a talk. But other than that, I think the next big shows will be, the Embedded Linux conference somewhere in the fall. It's been shifted around. There was supposed to be one in Europe, but it's not happening. So I don't remember the exact dates, but that will be the one big event that we might go and present something for. But otherwise, I think it's summer season's kicking in, and there isn't as much going on as there would be normally.
Yep.
We've just had a Zephyr Developer Summit, a very, very successful one.
Yeah, it was great.
I think 700 people came.
Yeah, and the talks are starting to get released, I believe, soon too. So they, yeah.
There's one about Renode. There's a panel I was on. So if you don't have enough of me yet,
just do the Michael playlist. Yeah, that's great. All right, great. Well, we'll link all this stuff in, and I appreciate you coming back and chatting more about all this open source stuff. I hope we can chat again in another 6 to 12 months and just hear what else Ant Micro's been up to. So thanks for joining today.
Perfect. Thanks for your time. It's been a pleasure, and thank you all for listening. Bye-bye.